So today onwards, we are going to start with a new lecture series on consumer behavior. So our first video will be on the topic of preferences. So when we talk about preference, we are basically talking about preference of an economic agent over a set of alternatives. So we have a set of alternatives and we are describing the preference over this set. Okay, let's denote the set of alternatives as X. Okay, and we have an agent or a decision maker who has this preference over this set of alternatives. So this set of alternatives, this can be a finite set or an infinite set. Okay, so let's say we are talking about, let's say the agent has to make a decision on buying a car. Okay, so we have a few alternatives, a finite set of alternatives, and within those this decision maker has a set of preference. Okay, so for the infinite case, we have a, let's say we have an budget set, and over this entire budget set, this agent can consume any combination of goods and services. So the set of alternatives is now infinite. Okay, so when we are talking about a preference relation, we use this symbol. Okay, so this is squiggle. This is the squiggle or our preference relation over the set of alternatives. So when there are, let's say there are two alternatives X and Y, and if I say that I prefer X over Y, I will write it like this. Okay, so this means I prefer X over Y, right? Or if I say this, I mean I prefer Y over X. Okay, so this squiggle has a few properties. The first one is completeness. Let me first write the entire property, then I will explain it. Okay, so for all X comma Y belongs to X, either X squiggle Y or Y squiggle X or both. Okay, so this means that over the entire set of alternatives, if we take any combination of any pair, okay, so any X comma Y pair like this, we will either say that I prefer X over Y or Y over X, or it can be both. When will this case occur? The both case, when I prefer both of them equally. So both of them are equally desirable to me. Okay. I can't I can't say it like this. I can't say that I don't have a preference, or I don't know about these alternatives, something like that, an ambiguous kind of an answer. So this can't happen. Either I prefer X over Y or Y over X, or I prefer both of them equally. Okay, the second property will be reflexivity. So this symbol, this one, this inverted A, this means for all. Okay. So for reflexivity, for all x belongs to x, x squiggle x. This means that every alternative is at least as desirable to itself. So this means that x is at least as desirable to itself, which means that if I pick any alternative from our entire set of alternatives, this is our set of alternatives, and if we pick any any single alternative, that alternative will be at least as desirable to itself. Okay, so now the third one will be transitivity. So for all x comma y comma z belongs to x, x squiggle y and y squiggle z, this implies x squiggle z. So this transitivity property says that if we take any triplet out of our set of alternatives, so this is our set and we are picking three alternatives from this xyz, and if from these three I prefer x over y and also y over z, so it will automatically imply that I prefer x over z. Okay, so these three will be our properties. First one will be completeness, then reflexivity, then transitivity. Okay, so this squiggle has two parts. One is this, and another one is this. Okay, so this is the strict preference relation, and this one is the indifference relation. If let's say I write like this means that I prefer, I strictly prefer, x is strictly preferred to y. Okay, this can also be written like this, x squiggle y but not y squiggle x. Okay, so this implies that I strictly prefer x over y. Okay, but if I write it like this means that I am indifferent between these two alternatives. Indifference. Okay, so after our properties of squiggle, I would like to talk a bit about utility representation of squiggle. Okay, so what is this utility representation of squiggle? First, let me give the definition, then I will give a few examples. So for any set of alternatives, in our case set x, and preference relation squiggle defined over x, the function u, the domain is the set of alternatives, so this is the domain, to the real line, this is the codomain. Okay, so this u, the function u represents squiggle if x squiggle y, if and only if u of x is greater than equal to u of y. This is not squiggle, okay? This is the greater than equal to sign. This is greater than or equal to, okay? And this is the squiggle. So this implies that if I prefer x to y, then utility of x is greater than or equal to y, greater than or equal to the utility of y. Okay, this is pretty much self-explanatory, because if I prefer the alternative x to y, the utility that I derive from x has to be either greater than or equal to y. Okay, so if there is a strict preference like this, then utility of x is strictly greater than utility of y. Okay, so this means that if I have a set x, set of alternatives, and a preference relation squiggle, this squiggle has these properties of completeness, reflexivity, and transitivity. So this is the domain and the codomain. So this utility function represents our preference relation if and only if this happens. Okay. So a few examples of our utility functions are, so let's say I have let's say there are two commodities x1 and x2. So utility of x1 and x2 can be this x1 times x2. This is our Cobb Douglas utility function. I'm giving a few examples of a utility function. Okay, this is x1 plus x2. This is a case of perfect substitute. Or even utility can be like this: min of x1 comma x2. So this is your complementary perfect complements. Okay, so these are a few examples of utility function, and I'm just going to give a brief about what we will do in the next video. Is that basically our job, or the decision maker's job, is to basically maximize the utility with a subject to its budget constraint. Okay, so this is the utility function u of x1 comma x2, subject to this is the budget set. P1 and P2 are the prices of the goods respectively, and M is the income. This is income. So this is what the decision maker's job. The decision maker only wants to maximize his utility given the budget constraint.